Chapter 3, pfrq 1. All right, here's a quadratic function. We're going to answer this stuff. Now, the first thing we're asked to do is to find the standard form. Now, this is a vertex standard form of g of x. Here's g of x by completing the square of the function. Man, it couldn't be more explicit for you. All right, so let's write this dude out. We have x squared minus 4x plus blank, because we're going to complete the square. Then we have our minus 5. Then we have to take away the blank. Okay, but what is the blank? What are we going to... Yep. So how do we find 4? We have to take the middle term, divide it by 2. So let's say the middle term is b, divided by 2, and then we square it. That's how you guys get the blank. And now it is a perfect square. This guy, he's a perfect square. And so we can factor him out to be x minus 2. We're going to square him, and then our result over here is 9. This is the standard form of g. So if g of x equals that. What's weird is we don't have to worry about finding the a. The a is just 1. So this was a simple one to find. Okay, next one. It says identify the axis of symmetry and the vertex of g. Now, there's 2 ways to do this. One way is to look at the standard vertex form, which is what we found, because vertex is hk. And if you guys remember what a parabola looks like, okay, if that's a parabola and that guy right there is hk, actually, we already wrote him right here. That guy's hk. That means h is going to be right in the middle. That is your axis of symmetry. It is an x value, but it equals h. So your axis of symmetry is just going to be -2. So you can say AOS for axis of symmetry, x equals, oh, yep, you're right, +2. Because you always have to think the opposite when it's inside the group with the x. And their vertex is 2, -9. Yeah, this is definitely not at 2, -9, but anyways, you guys get the point there. Okay, if you didn't have vertex standard form, you would use, what's that thing called? That formula. X equals -b over 2a. Okay, so b would be this 4 right here. And so we would just have to go -4. We plug -4 into there, which would be -4 over 2a. A is 1, and so what would we get? We would get +4 over 2, which equals 2. You see? We got the same axis of symmetry, so 2 ways to do it. All right, next guy. Find any intercepts of the function. Any. So that means y-intercepts and x-intercepts. So if you're looking for y-intercept, that's the easy one to find. You just have to know that x equals 0 for y-intercepts. So we plug it in. And you can plug it into any g version of g that you have. We have this version of g and this version of g. This one looks easier if I do it with that one. So let's plug it in. We have g of 0, and that equals 0 raised to the second power minus 4 times 0, and then minus 5. And so what does that equal? -5. So what is your y-intercept? -5. Now you can just write -5 like that, or you can say 0, -5. But there's nothing that says write it as points, so it doesn't really... Oh, no, it does. It says right here, label as points. So we got to have 0, then -5. All right, next, to find the x-intercept, we know that y equals 0. So we're going to plug 0 into the y. What is y in this function? Actually, I want to use this one. I don't want to solve it with this one. This one looks easier because we can use the square roots to get rid of that squared, which is very nice. G of x is your y. So I'm going to plug 0 into the g of x, and then we have x minus 2 raised to the second power minus 9. Add 9 to both sides. X minus 2 raised to the second power. And then what would you do to find the x? You would square root both sides. Whenever you square root as an inverse operation to get x alone, make sure you have your plus or minus. So you should have plus or minus 3 equals x minus 2. And then when you add 2 to both sides, that would be x equals 2 plus or minus 3. So that would be 2 plus 3 and 2 minus 3. What is 2 plus 3? That is 5. So one of our x-intercepts is 5. So we go 5, 0. And then what is 2 minus 3? That would be -1. -1, 0. There you have it. Those are our solutions. All right, next it says state the domain and range of the function in interval form. That's interval notation. Okay, so now parabolas, you should be used to these guys. Parabolas have a domain that is all real numbers. So we're going to say from negative infinity to positive infinity. And if you're thinking about a parabola, like I'll just draw the parent function of the parabola right here. Oh, it's kind of ugly. But the domain, which are x values, you can plug anything into it. Even the x value that's way over here. This line will eventually get to it, and he would be included. So what about our range? The range is what's really affected by the function. So let's think about that for a second. Do you guys remember what our vertex was? I think it was 2, negative 9, right? Right? Now, if it's 2, negative 9, let's go ahead and put it on this graph over here. 2, negative 9, that's right here. Now, do I open upwards or downwards? Upwards. And so you go bam, bam, okay? And then, and I know that those are there because there's no A. There's no A that's saying like, oh, you got to do this or that. Oh, you know what? We know the what are they called? The intercepts. Wasn't negative 5 an intercept? Yeah. And what were the other two intercepts? Negative 1 and 5?
Yes.
Oh, cool. And then since the axis of symmetry goes through the vertex, I also know that this point exists because I'm just mirroring that guy. And so there you go. There's a nice little sketch of our parabola. And this guy goes down. It should be curvy at the bottom. I'm having a hard time right here. Okay. All right. So what is our range of that? I mean, I'm visual, so I visualize this graph to figure out the range. What's the lowest y value? Looking at this y-axis. Yeah, negative 9. Negative 9 is our lowest. Okay. And because negative 9 is our minimum, that means we're going to go to infinity for the maximum y value. So there you go. Oh, wait. I did something wrong. What did I do? Yeah, not parenthesis, bracket. Why is it bracket? Because negative 9 is included, foo. Negative 9 is in our range. All right, what does the last thing say before I answer your question? Use parts A through D to graph. It should say to graph the function. Oh, we did. Did we use the intercepts? Okay, was there any other information that we were given? No, we weren't, huh? All right, so that one's done. That was a really good question. So the question was, where did K come from? We found negative 9 right here. Wait, where'd he go? Right here. We found negative 9. K is right here. Here he is. HK. So K is the number that's adding or subtracting to the operator, which is squared right here. And that's how you find the y value for the vertex. Very nice. And there's another way to find the y value. Like, let's say if you did it like this. You went negative b over 2a and you found 2. How would you find negative 9? What would you do? Yeah, you'd plug it in. So you would go g of 2, and you could plug it into that form, or you could plug it into that form. I'd probably use that one, just because what if I did something wrong on that one? So it'd be 2 squared. Is that minus 4? Yeah, minus 4 times 2. And then you have minus 5. So it'd be 4 minus 8 minus 5. These would cancel out and make a, well, they don't quite cancel out. But anyways, if I get rid of them, I get a negative 4, and then I have 5, then I get negative 9. So there's your y value for the vertex.